An F-type. The F-type connector is the standard threaded connector used for coaxial cabling, primarily in cable television, satellite television, and cable internet installations. Invented by Eric Winston in the early 1950s, it was designed as a low-cost, high-performance solution for residential radio and television. Unlike the click of an RJ45 or the twist lock of a BNC, the F-type utilizes a screw-on mechanism that provides a highly secure and electrically stable connection. This physical security is essential for carrying high-frequency radio frequency signals over long distances without the risk of the cable being pulled out accidentally. The anatomy of the connection. The most unique technical aspect of the F-type connector is that it is a male connector that lacks its own internal center pin. In almost every other cable type, the connector has its own metal pin that inserts into a socket. In an F-type connection, the connector uses the solid copper center conductor of the coaxial cable itself as the pin. When a technician prepares a coax cable, they strip away the outer jacket, the braided shield, and the dielectric insulation. This process leaves about a quarter-inch of the copper core exposed. When the F-type nut is screwed onto a jack, this copper core slides directly into the female socket. This design minimizes signal loss, also known as attenuation, because there is no bridge or solder joint between the cable and the connector. The data travels on a continuous piece of copper from the provider's box all the way to your modem. Performance and shielding. F-type connectors are typically used with RG6 or RG59 coaxial cables. For modern cable internet and high-definition television, RG6 is the industry requirement. It features thicker shielding and a larger copper core, which allows it to handle the higher bandwidth demands of gigabit internet. The threaded design of the F-type is critical for protection against electromagnetic interference. Because cable internet signals occupy the same frequency space as many over-the-air radio and cell signals, any leak in the cable can cause noise to enter the system. By screwing the connector tightly onto the jack, the metal-to-metal contact creates a 360-degree shield that prevents outside noise from scrambling the data. Variations: compression versus crimp. In the field, you will encounter two main ways of attaching an F-type head to a cable. The first is crimping. This is an older method that uses a hexagonal tool to crush a metal sleeve around the cable. While fast, it often results in leaky connections if not done perfectly. The second is compression. This is the modern professional standard. A compression tool pushes the internal components of the connector together, creating a permanent, watertight, and airtight seal. Most modern cable and satellite providers require compression fittings to ensure the stability of the high-speed return path used for internet data. Troubleshooting and the finger-tight rule. The most common failure point for an F-type connection is a loose nut. If the connector is not screwed on tight, the shielding is compromised, leading to pixelation on TV channels or synchronization errors on a cable modem. Technicians often find that a customer's internet issues are solved simply by using a 7/16" wrench to give the F-type connector a quarter turn past finger tight. Another common issue is a bent center conductor. If the copper pin is bent even slightly during insertion, it won't seat in the socket, resulting in a total signal loss. If you see a no signal message, the first step is to unscrew the cable and check if the copper core is straight and centered.